So for our synthetic data generation, we'll take a 3D scan of a product with a LiDAR and RGB sensor. Once we've taken that scan, we have a asset of that product in 3D space. When we say synthetic data generation, we're taking we're pulling from our library of 3D scanned products and dropping them in 3D space. So we'll say, let's pick 10 corn dogs from our library of 30, drop them onto this conveyor belt that we can specify as either blue or white, and let's see how the corn dogs settle in that simulation. Normally, what other companies are doing today is they take a 2D picture and hand label where all the corn dogs are and what defects are. Instead of us hand labeling, we're saying generate a scene that we know will have a certain number of corn dogs. It allows us to much more rapidly iterate and have much better data going in compared to traditional AI that is using like reinforcement learning or training. So we're trying to have a balancing act of provide a customer with an object model that works for them out of the box, but we fully understand that there are a lot of different applications and people need to tweak things for their specific application. So with our recipe builder, I can go in and specify exactly what tolerance classifies a defect. So if you were to hire a person to inspect corn dogs, you wouldn't need to tell them what a corn dog is. They have that understanding. You need to spend some time and say, if there's this much displaced breading, that is a defect. If the stick is this broken, that is a defect. With our recipe builder, there's no more AI, it's totally rules-based. The user can go in and specify if the corn dog has 30 millimeters of displaced breading, that constitutes a defect. If a customer has much more strict guidelines, maybe 30 is too much, maybe we want to go lower to even 20. Maybe a customer doesn't care and they're selling cheap stuff and they can go up to 100 millimeters. So the recipe builder allows customers to stay completely in control of their application. So a lot of the times when you're installing vision, you have to install the vision system and then you have to develop the application and you have to do some testing and you have to tweak it. And it takes months to install a system typically. Because we're doing pre-trained object models and we are using synthetic data generation, we can iterate much more quickly and we can deploy in days, if not weeks. In terms of integrating with existing machinery, we can use Ethernet IP communication or discrete I/O to either talk to a PLC or talk to a different robot that might be moving things or a simple machine that just needs to trigger some sort of actuator. A lot of traditional machine vision systems will fail as lighting changes because you need to key in different parameters and different pixel values. The good thing with us in our pre-trained object models is that we're able to synthetically represent different lighting environments. So we can account for low lighting variability, we can account for very bright hotspot lighting, we can account for normal lighting, and essentially we'll chat with the customer to understand how much variability they need to account for, and we're able to, with a push of a button, simulate that. Because our system is working with food and there's so much organic variability within food, we are very robust to different sizes and shapes. So if there's a big harvest one year, you wouldn't need to change any of the object model, maybe just change some of the recipe settings, and that's if you want to change the recipe settings. If you are moving the system vertically, there is a calibration step you would need to do. The calibration is to just ensure that we're getting accurate dimensional data. So we have a fiducial that we put on the conveyor belt. You would run a quick 5-minute calibration process, and then you're up and running, ready to go. If you can identify defects early in the process, you can prevent defects from happening and save money. A good example is there was a egg roll machine that has the egg roll paper, and then it spits out the egg roll filling in goop, and then it goes and it gets wrapped up and frozen and sent to the customer. If that initial egg roll is broken, the initial flat part, when you cook it and add the filling to it, it's going to break. If you know that it's broken before you dispense the goop, the sheet itself is 2 cents and the filling is $1. So if you can say, don't dispense the goop on this and just get rid of it, you actually say you don't waste more of the product. So I think that's one really good example. Another one is for chicken products. Companies are paid by the pound, but they also can't have too much fat or the chicken will get rejected. If you can use machine vision to key an AI to key in the exact right amount that is acceptable for being low trim, you get paid in grams, so customers can save money and have higher yields.